Hi, everyone. So this is following up on the lecture that we had yesterday, which was Wednesday. I introduced to you covalent compounds and how covalent compounds are different from ionic compounds. So I'm going to say it again, and this is a very important point, that there are no ions in covalent compounds. Ionic compounds contain ions, and that is why they're called ionic compounds. That might seem obvious to you, but as we go forward with this, I think that there will be times when you'll get confused, you'll get them mixed up, you will get tripped out. So I'm giving you a heads up there, and let's kind of pick it up where we left off from last time. Last time I gave you an example of hydrogen and chlorine coming together to form a covalent bond, right? I want to continue with some other examples of that. What I just put together here is just a brief overview of where we left off last time. So just in case you needed to see this again. So hydrogen and chlorine are coming together to form a covalent bond, all right? This is a shared pair of electrons right there. And another way of writing that shared pair of electrons is to draw a line like that, okay? That is called a covalent bond. A covalent bond is a shared pair of electrons. And that's what I wrote right there. It's a shared pair of electrons. It's a covalent bond. Let's look at some other examples. This next one, let's go with water, H2O. Everybody knows that water is H2O. That means that there are 2 hydrogens for every 1 oxygen in a molecule of water. This is the Lewis dot structure for hydrogen. This is the Lewis dot structure for oxygen, and another hydrogen Lewis dot structure, okay? So I'm drawing it in this way so that it's going to be easier to draw the covalent bonds when we come to that, okay? So what electrons are going to be shared? Well, these 2 electrons will be shared. They will form a covalent bond, and these 2 electrons will be shared to form a covalent bond. That's 2 covalent bonds. Another way of writing that would be to say, okay, I got these lone pair electrons, I've got a hydrogen and another hydrogen. All right, now, it's really important to understand that the reason that we have a stable molecule, and I'm going to draw some circles here, I'm drawing a circle around the octet that is around oxygen, 8 electrons around oxygen. This represents 2 electrons. This represents 2 electrons, so that's 4 electrons, plus 2, 6, plus 2 is 8. There's an octet of electrons around that oxygen. There's also an octet, so to speak, around the hydrogen. Now, for hydrogen, the octet is 2 electrons, right? Because it is mimicking the electron configuration of helium, which is stable. All right? So we've got 2 covalent bonds there, and the circles are just representing the octets. If we've got octets all the way around, we've got a good structure, molecular structure. Another way of writing this is, I think we'll just leave it at that, okay? But I'm going to rewrite this so you can see the Lewis dot structure. The answer does not include those blue circles. I was just showing you the octets. Now, it's also okay, by the way, just if you're wondering, to draw this like this. There's nothing wrong with that. Okay? Let's try another one. All right, let's try carbon dioxide. All right, now this is going to be a little bit different, okay? Here's the Lewis dot structure for carbon. Here's the Lewis dot structure for oxygen. Here's another Lewis dot structure for oxygen. Okay? All right, I'm going to draw circles or ovals around the electrons that will pair up to form covalent bonds. But this is going to be a little bit different than what we saw before. Okay? These two electrons are going to form a covalent bond. These two electrons are going to form a covalent bond. These two, okay, I got to draw it like this. These two electrons, covalent bond. These two electrons are going to form a covalent bond. And what we end up with is this. I'm going to draw this in dots, okay? So, okay, that's oxygen and oxygen. These are the lone pair electrons around oxygen, okay? What I've just drawn here are double bonds, okay? Each side of this carbon has a double bond. This is a double covalent bond. And that's a double covalent bond. And another way to draw this is like this. So carbon, double bond, oxygen, lone pair electrons, double bond, oxygen, lone pair electrons. Okay, why is this right? All right, this is right, and because now I'm going to draw octets. I'm going to draw circles around the octets. There I've got 1, 2, 3, 4, 5, 6, 7, 8 electrons around oxygen. That's an octet. I've got 8 electrons around the carbon. 1, 2, 3, 4, 5, 6, 7, 8 around the carbon. That's an octet. And I've got 8 electrons around this oxygen. And that's an octet. 1, 2, 3, 4, 5, 6, 7, 8. We've got octets all the way around. That means we've got a stable molecule and we are good. So I'm going to just write a little note here saying each, not eat, each atom has an octet, which means it's stable. Okay? So, in a way, it's kind of like a puzzle. You know, when you're putting these structures together, how am I going to do it in such a way that I'm going to form octets? Okay? Let's try another one. Okay, here we're going to go with a diatomic nitrogen atom. Molecule, sorry. Diatomic nitrogen molecule. Okay, that means there are 2 nitrogens. I am going to draw a Lewis dot structure for one nitrogen, and I'm going to draw a Lewis dot structure for the other nitrogen. Okay? These 2 atoms are going to come together to form covalent bonds. These covalent bonds are going to be the pairs of the electrons. That's a pair of electrons that are going to form a covalent bond. That's a pair of electrons forming a covalent bond. This is a pair of electrons forming a covalent bond. That leaves us with a structure that looks like this. And what we have here is a triple covalent bond. Okay? So covalent bonding, you can have single bonds, you can have double bonds, you can have triple bonds. We're going to get more into this later. All I want right now is for you to recognize that this is a possibility. That's all I care about right now. okay? Let's just run through a couple of other examples, and then I want to show you one more thing. Let's try a couple more examples, all right? Okay, so we have a couple of examples here. Hydrogen, here's the Lewis dot structure for hydrogen, here's the Lewis dot structure for hydrogen, and we're going to form, I think it's going to be kind of obvious, right? We're going to form a molecule of hydrogen that looks like this. That's a diatomic hydrogen molecule. Or you could draw it with a line, all right? What about oxygen? So diatomic oxygen. Here's oxygen. By the way, when I say diatomic, di means two, okay? All right, these two are going to come together to form a covalent bond, actually a double covalent bond, sorry. And please don't worry about this right now, all right? We're going to get more into this very soon. Right now, don't worry about the details about what I'm doing. I just want you to see some other examples of molecules. So this would be a double bonded oxygen. It's a diatomic molecule. Here's another example. Here's carbon monoxide. You've probably heard of carbon monoxide. This is probably not a great example to show you right now because I really, my goal is not to confuse you, but I'm just going to give you the final answer here. Let's not really get into the weeds in this yet, okay? Trust me, don't worry about this. I just wanted to show you another example of a triple bond. Okay, so on this page, we've got a single bond with the hydrogen, we've got a double bond with the diatomic oxygen molecule, and we're seeing a triple bond with the carbon monoxide. Trust me, we're going to do a lot more of this. I just wanted to give you some examples, and what's probably most important about any of this is that you can see that we're forming chemical bonds that do not involve ions anywhere, okay? So what we're going to do now is I want to show you how to do naming of molecular compounds. These are molecular compounds that we're dealing with now, okay? All right, so when we're naming covalent compounds, we're going to follow this scheme. Guys, this is different than what we were doing with the ionic compounds, okay? And this is where you're going to start getting confused because you're going to get these things mixed up. I promise you, so please pay close attention to what we're doing here, okay? And this is really only going to come with practice. But we use these prefixes when we're naming molecular compounds or covalent compounds. What do these prefixes mean? Well, you probably already know, but I'm just going to tell you anyway. So mono means one, and di means two, and tri means three, and tetra means four. I'm going to write the number. Penta, 5, hexa, 6, hepta, 7, octa, 8, nona, 9, and deca is 10. All right. That's easy. Now, I think the best way to do this is just to jump into some examples of naming covalent compounds. All right, so let's try some examples here. All right, now I'm using these molecules as examples for a reason. All right, I want you to understand the reason I'm using nitrogen oxygen molecules. You can see that nitrogen and oxygen can come together in a variety of different ways, okay? I cannot just call a molecule nitrogen oxide, okay? I can't do it because there are all kinds of ways that nitrogen and oxygen can come together to form a molecule. So in the name, we have to be specific. We have to specify, how many nitrogens are there, how many oxygens are there. Okay, so I'm going to now use the prefixes that I just showed you to name these compounds in front of me. And I think you're going to find this really easy, okay? First thing I'm going to do is I'm just going to call, here, I'll do this in red. I'm going to first name the first element, so nitrogen. And since there's one oxygen there, I'm going to call it nitrogen monoxide. Okay? Technically, I'm not going to say monooxide. Okay, I'll call it monoxide. Nitrogen monoxide. Okay? Now, in this next compound, I have two nitrogens. I need to specify that I have two nitrogens. Di-nitrogen monoxide. Okay, what about the next one? Again, nitrogen. And this is dioxide. Okay? This next one, di-nitrogen pentoxide. All right? Not pentaoxide, but pentoxide. When you get the two vowels together, you just, I'm not going to say pentaoxide. Okay, I call it pentoxide. And not monooxide. I call it monoxide. Okay, what about this last one? Di-nitrogen tetra or tetroxide. Tetraoxide. I mean, honestly, if you said tetraoxide, I wouldn't be like, no, that's wrong. This is fine. Okay. Hopefully you're getting the swing of this. Okay. Let's try another one. How about carbon and 4 chlorines? Okay, this is a molecule. I'm going to call this carbon tetra. Oh, come on. Tetrachloride. Okay. We already saw carbon monoxide. Okay. Carbon monoxide. All right, maybe a couple more. How about CO2? You have heard of this. Carbon dioxide. Okay? All right, one last one, and I'm doing this on purpose because I know that you're really comfortable with what you're seeing right now, and you're like, yeah, this is the easiest thing I've ever seen in my life. Okay, what about this? Aluminum. Okay, you might be tempted to call this di-aluminum trioxide. And guess what? You are wrong. Why? Because this is an ionic compound. And we follow different rules for ionic compounds. I'm just going to call this aluminum oxide. There's only one way that aluminum ions and oxide ions can come together. Aluminum ion, oxide ion. If I do the crisscross, whatever, aluminum oxide. This is the only way that aluminum ions and oxygen ions can come together. So I don't need to specify a di or tri or penta or whatever. There is only one way, and that's it. This formula is aluminum oxide, and if I go to Pluto and try to mine aluminum oxide, this is what I would find on Pluto or across the universe. Anywhere if I was to find aluminum oxide, that's what I would find. Okay? Now, just to be clear, I have to specify with these molecular compounds how many of the elements are in those compounds. Okay? So, I will have homework for you to get some practice, and I'll see you in class.